Sketch a graph of x squared minus y squared minus 10x minus 10y equals 0. Let's group the terms together based on variable so that we can complete the square. We've got x squared minus 10x and then minus y squared minus 10y, and that equals 0. Now before we complete the square, we're going to have to factor out that negative in front of the y squared. So we've got x squared minus 10x, and then minus the quantity y squared plus 10y equals 0. Now to complete the squares here, we've got negative 10 divided by 2 is negative 5, and negative 5 squared is positive 25. So we're adding 25 there. And then also in the parentheses with the y, we're also going to have to add 25 to complete that square. But what we're really doing is subtracting 25 because of that subtraction out front. So we've added 25 and subtracted 25 on the left, and those cancel each other out, so we don't have to do anything on the right-hand side to balance the equation. It's already balanced. Now, if we go and factor this, it gives us x minus 5 squared minus the quantity y plus 5 squared equals 0. And it almost looks like it might be a hyperbola because we've got a positive x squared and a negative y squared, except with a hyperbola, it's got to equal 1, and here it's equal to 0. And there's nothing that we can multiply or divide 0 by to end up with 1, so this ends up being a degenerate hyperbola. To figure out what the graph is going to look like, what we want to do is we want to get this y plus 5 squared term to the other side, and we want to try to solve for y in terms of x. So when we do that, we get x minus 5 quantity squared equals y plus 5 quantity squared. And to try and get the y alone, we've got to get rid of the square, and to do that, we take the square root of both sides. So we get y plus 5 on the right and x minus 5 on the left. But remember, with the square root property, we need a plus or minus symbol on one side because the square root could be positive or negative. We're going to put that on the left-hand side so that it's with the x. And now what we're going to do is we're going to actually look at these separately. We're going to look at the equation where this is a positive x minus 5 and then where it's a negative x minus 5, because each of those is going to give us a separate line to graph. So we've got, and I'm also going to switch the two sides because we like to write y on the left-hand side. So we've got y plus 5 equals x minus 5, or y plus 5 equals the opposite of x minus 5. Now for this first one, we subtract 5 from both sides, and we get y equals x minus 10. And then for the other one, we need to distribute that negative. We get y plus 5 equals the opposite of x plus 5. And if we subtract 5 from both sides, we get y equals the opposite of x. So these are going to give us two different lines, which are effectively the asymptotes we would have had if this 0 was a 1. But because it's a 0, instead of getting a hyperbola, we get the degenerate hyperbola, which is basically the asymptotes. So y equals the opposite of x. That is going to be a line with y-intercept 0 and slope negative 1. So that's going to be going down in this direction. And we can draw the other side up there. And then y equals x minus 10 is a line that has a y-intercept of negative 10, which is a little bit off the graph. That's going to be down here. And then it's got slope positive 1. And so it's going to be going up as we go to the right. It's going to look like this. And so this ends up being the graph of x squared minus y squared minus 10x minus 10y equals 0. And this is a degenerate hyperbola, which gives us 2 lines.